Asymptotes are imaginary lines that influence rational functions and their graphs. We always draw asymptotes with dashed lines. There are three different types of asymptotes. The first type is a vertical asymptote. The second type is a horizontal asymptote. And the third type is an oblique asymptote. I will show you how to find each type of asymptote in separate videos. For this video, we'll look at finding vertical asymptotes. Vertical asymptotes are imaginary lines that divide the function. Functions never cross vertical asymptotes. I'll abbreviate vertical asymptotes as VA. They never cross a vertical asymptote. Instead, they skip over it. Vertical asymptotes are x values. And in order to find a vertical asymptote, we set the denominator equal to 0 and solve for x. I'm going to draw a graph now and show you the general behavior of a vertical asymptote. Let's suppose that we have a vertical asymptote along this dotted line right here, and that our function is increasing on the left. So what happens is that the function will increase, and then it will reach the vertical asymptote, and it will not go through it, but instead follow it along forever. So notice that the function is increasing on this left side. Now it'll skip over the vertical asymptote and it will go on the other side of it, and it will start at the opposite end. So it will start at the bottom here, follow the vertical asymptote along, and then head off in the direction on the right. Notice that it is also increasing on the right side. So in general, this is a behavior of a function when it runs into a vertical asymptote. The function is not defined at a vertical asymptote. Instead, it skips over it. Now let's take a look at a few examples on finding vertical asymptotes. The first problem is y equals 3x minus x squared divided by x squared plus 5x. Now let's try to factor the function first. Notice that in the numerator we have two terms with x's, so we can factor out an x here. That'll be 3 minus x. And the same idea in the denominator. There is an x in common between x squared and 5x. So factor out the x, we have x plus 5 left. Now the x values will cancel out. So we have 3 minus x divided by x plus 5 for the function. Now we'll set that denominator of x plus 5 equal to 0 and solve for x. So we get a vertical asymptote at the value of negative 5. On the graph, when we draw a vertical asymptote, we go over on the x-axis to negative 5, and we draw a dashed line that is vertical. Alright, so that's where our vertical asymptote would be on the graph. Looking at another example, the function is g of x equals 8x plus 7 divided by x times x plus 4 times x minus 1. Now notice that this function is already factored for us in the denominator. So we'll set the denominator equal to 0 to find vertical asymptotes. And then we need to set each factor equal to 0. Okay, the first factor is x. Well, x equals 0 is a vertical asymptote. The next factor is x plus 4. When I solve for x, we get negative 4 here. And the last will have positive 1. So this particular function has 3 vertical asymptotes. We can label these on our graph. So we have a vertical asymptote at 0. We have a vertical asymptote at 1. And on the left at negative 4.